o'clock.
I didn't know that because I thought it was due at 12, like the last quiz. The last quiz to be submitted, quiz 7 was due at 12 o'clock noon.
No, I told you last time until before your class start today.
So we can't turn it in right now because it's finished.
I don't think you can turn it. Blackboard is cut it out. See.
Oh my God, bro.
Oh, come on. I will show you my my screen. I will show you my screen.
I just thought it was due at 12 o'clock noon. That's why I didn't turn it in. Oh my God.
Last quiz.
I had an 8 o'clock class. I just got out of that class.
Last quiz he did that.
This is quiz 8. You can see my screen, right? So quiz 8 is this is March 27, 9 a.m. That's a due date. So if you click here, then already passes. See, if I go into the see, look at this. This one is a Friday, 9 a.m. That's a due time. So after that, I don't think so. This is okay. I don't think it's okay.
I can still turn it in, can't I?
Okay, so let me see. Cancel.
Because I did not know it was due at 9 because the last one was due at 12.
No, that's the last one. I didn't give I gave you 48 hours.
Oh my God, I cannot get a 0. I busted my tail on this quiz.
Okay. All right, I was going to post a solution today, but okay, fortunately I did not. All right, so that I will change it. Okay, this time is a very special, okay? But from now on, I'm not going to do that anymore. Okay, so I gave you I emphasize 100 times the 48 hours. So, the last quiz 7 is posted by my TA.
Oh,
TA.
see,
Yeah.
That's why I didn't know because I thought you had posted that.
Right. That's the reason. Okay. So
okay.
Friday 12. Okay.
I'm about to turn it in right now.
Okay. So no, you don't have to do that. Take your time until 12 o'clock. I'm gonna receive you. Okay.
All right.
Thank you.
Thank you.
Okay. This is a special. So this is special. Okay. So that. Okay, so this is okay. So I think now it's going to be today. What? This is. It was available. Okay, noon. I think this is okay. Ignore this guy here. So it one more time. Okay. All right. So this is special case, but from now, I'm not going to do that anymore. Okay.
Yeah, I understand. I just thought that you had posted the last one. I didn't know that was your TA.
Okay. All right. So now. Okay. From now, it's going to be Tadi. Okay. Save. Okay. About the exam also, I would do that. Okay, let's do the test. Exam number 2 also I'm gonna post it here, like quiz number 8. Okay, and exam number 2 is posted like this, and then I will give you only okay. Now let's define the time. The 8 from 8:50, okay, 8:50 to 8:50 to 10. Okay, I don't think because this is 4 problem plus one extra credit,
Do
so
we
5
have till
problem.
midnight?
No. I mean, I give you only.
People have might have a 10 o'clock class.
I just have classes the rest
I
of
got
the
a
day.
class.
Yeah,
I got 10
I
o'clock
have-
class right after.
I got a class right after this.
But this is actually a 15-minute exam. So what I'm saying that because you have the 10 o'clock class, that's the reason last time when we in class, so we normally has from 10 minutes earlier than 9 o'clock to I give you 55 minutes. Okay, so I can do like that, exactly same thing. But because of you take a picture and upload that something like that, so I'll give you around the 15 minutes more, 15. So what I can do is the 8:50 to 10 10, okay, 10:15. Okay, let me define one more time. All right, 8:15 50. Okay, you can write down.
That just doesn't feel like enough, Dr. Kim. That
Yeah, and I
just
have a
doesn't
class.
feel right.
I got class at 9 too. So
9 to this is 9 o'clock class. What
oh,
is
this is on 9 o'clock.
Yeah,
Why not do the
just,
original 2
yeah.
hours?
Yeah, let's
So what I'm saying,
chill
this
out
is
for a
just
second.
like an in-class exam, okay?
But I'm
In-class
not
exam.
in class. I'm at home with distractions and stuff. This is different.
Well, this is exam. This is not a normal class. This
This
is
is not a
exam.
normal class.
Yeah.
online.
Okay,
Online.
but I cannot do that. Give you enough time anyway.
You can. You just don't
one,
want to.
not like a quiz. This is the exam. So this is 1 hour. So what I can do is exactly the same with the 8:50 to 10. Okay, 10. Okay, last time I told you 10:30. Okay, 10:30. So this is the maximum I can give you. Otherwise, you can. This is you okay. I think I cannot see at all whether how you're going to do that, huh? Or you can I can watch you all open the video and then just like an in-class quiz. So this is maximum I can do, and even so that this is kind of a open book, open note like that. That's very different, isn't it?
Yes, you're right. You have distractions and stuff at home.
Yeah.
So 8:50 to
that part I
10:30?
don't know. Okay,
I can't
8:50
leave
to
home.
10,
I'm locked now.
10:30. Yeah, that's maximum I can do. Because some other people has a class, 10 o'clock. This is up to you. But okay, so you need to only 4 problem. Each problem, I think you need to spend at most 10 minutes. Okay, so you should be able to do that.
Dr. Kim, one more question. For the exam, can we submit it kind of the same way we did for this quiz, where we could just write it down on some paper and just box our answers?
That's a good question. Okay. Yeah, but the reason I give you only 1 page or 2 page box, then only inside of box that I'm gonna grade it. Okay, and then because I consider no partial grade, but in case suppose you solve correctly, but last minute when you copy to the exam box, then you may have made a mistake. Because for example, 25, so you may something like 35, something like that. In order to consider those kind of error, then I think I need your solution process. Okay, so if you submit the solution process, the if everything is pretty good, but something really mistake, by miswriting, something like that. Those cases, I should be able to consider that. Is that clear?
Yeah, I get it. So just show all your work, and if as long as you're not totally off,
Yeah.
you can get consideration.
Right.
Okay.
So for example, suppose you solved correctly, but the last minute you write on the paper, exam paper, something like that, a little mistake, then in the case you don't submit that your solution, that case is I consider 0, something like that. Okay. So in order to prevent those kind of the grading mistake, then I might be able to consider if you submit your solution paper. Okay.
Okay. Thank you so much. God bless.
But
That's so nice.
the condition is in the solution, in the solution paper, top line, you need to write your name, ID, exam number 2, just like an exam paper. Okay. The top line. Okay. You understand what I'm saying?
Okay, so
Okay.
in that case, for
every pages you need to do that.
In that case, I would have a separate sheet just for my answers.
Right. Separate white paper or something.
Okay, and then one sheet just for my. Okay, so I can't combine the two. Okay, I get it.
In white paper. So first, the top line, you need to write your name, right, and then banner ID, exam number 2, okay, date, okay, that every pages. Okay, you understand?
Okay, I get it.
Yeah.
Thank you so much.
And then also one more condition is, in the case of somebody copy, and then I check it out. If something exactly identical writing and something, then I will consider it as a cheating. So those conditions you accept, then I might be able to consider your solution paper.
Oh, so if we write our solution, but our solution is completely different from the answer we actually have, that would be like considered cheating for you?
I mean, these, 2 person exactly same thing. So somebody copy and send to you something, and then exactly same thing, then I consider it as a cheating. The cheating policy is on the syllabus. Okay.
Okay, I got that.
I'm sorry that I have to do that. Okay, so everybody understand about the exam next Wednesday, right? So I'm going to open, as I told you before, 8:45, and then if you have a question, because in the case of you have a question, then I open this Zoom from 8:45, and then you can see from 8:50, and then until the 10:30. Okay, then I'm gonna I can wait until 10:30 in the Zoom, and so if you have any question, then I think you might be able to ask a question. Okay, it's okay.
Yeah, that's good.
Okay. All right.
Dr. Kim,
Yeah.
I don't quiz 8 yet on the blackboard.
You can see the quiz 8 at Blackboard here, right?
Yeah, I don't see it on my screen.
Any other person? Any other person cannot see that? I already submitted it, this one. Until noon, today noon, you should be able to see it.
I don't see it.
Still 9 a.m.?
I don't see it at all. Is it on the quiz test exam?
So this one, you're here. You see, okay, you see my screen, right? So this said that the due date is 12 p.m. Huh? You
Is
can
it
see
on the
that?
quiz test area?
This is it.
Is it on course material or on quizzes?
This is quiz 8.
Yeah, where is it? On the blackboard.
Blackboard is a quiz and test. Oh, still you don't know about that?
We don't see it here.
You don't see it? I don't know. What can I do there? This is,
Did you submit? Did you send it?
I did. A minute ago, I corrected it, extended the time until noon. Okay?
It's not here. Let me log off and log back in again.
Yeah, please. I think you must be able to do that because I extended it already. No, this is last available, but so you student, click this guy here, 8, quiz 8. So I click it.
Yeah, I can see what he says right under your cursor, Dr. Kim.
Uh-huh.
Read that sentence beside availability. It says item is hidden from students. I see the due date there. I understand what you're seeing, but in that, I don't know where it is, but in that one line, it says item is hidden. So it has to be unhidden somehow.
Yeah, you probably have to
right
click
there
something
under
to make
availability,
available.
Dr. Kim. It says item is hidden.
Okay.
So I'm not sure how to unhide it.
So what should I do now? Okay.
For the ones that just haven't submitted it, did you want us to email it to you? Or we can email it to the TA. And you notify him that you extended it to 12.
Yeah, please. Yeah, right. I think he already know about this because he can access the Blackboard. So why don't you send yours to the TA and then explain what we're talking about, okay?
Okay.
All right, good.
That's cool. All right.
Okay, all right. So now okay. I think everybody clearly understands how we're going to deal with the exam now. Okay. One more time, I emphasize. So next Wednesday, I'm going to be here open from 8:45, and then you can see the exam number 2 from 8:50 until 10:30, and between that time you must be able to submit it. Also, I sent the email about how can you scanning. If you have if you have a smartphone, then how you scanning and then make a PDF file and submit to you. I think you already received my email. Okay, so department sent me like that. So I think that's very convenient by using your cell phone and scan the documentation and make a PDF file and submitted. I think that's very good, the instruction. Okay. Okay, so today I think I would like to briefly cover about the chapter 3, even if chapter 3 is not inside of the exam number 2. Okay, so chapter 3, from chapter 3, there's a discrete time signaling system. This is very important. Discrete time signaling system is, I think, more important than chapter 2. Okay, so I think you need to pretty much understand. I think if you got a job in job market, probably the discrete time signaling system is much important than continuous time.
So Dr. Kim, this is the start of the material for exam 3, correct?
Right. Exam
okay,
3,
gotcha. Thank you.
Right. And exam 3 is chapter 3 and chapter 5. So
Okay.
this is chapter. This is chapter 3-1. 3-1 means that after chapter 3-1, we're going to go to the chapter 5. So lecture note to chapter 5 already posted, I think. Okay.
You
So
can't open it.
it's closed already. April. No, I think you can do April until April 1, I think. So
there's no file under chapter 5.
chapter 5, yeah.
Yeah, there's no file.
attached. There's no file attached.
Huh?
There's no file attached.
Is that right?
Yes, that's right.
Okay, then I will do. Are you sure?
Yes.
100%.
100%.
Right now.
Oh.
Yeah, it's been that way for about a week.
Okay, let me see. Okay. Let me see. Okay. Chapter 3 is okay. Oh, chapter 5. Oh, come on. Chapter 5. Okay. Chapter 5. Oh. Okay, so April 1 is enough time, right? So next Wednesday, so you need to do that. Okay, so only thing that I need to do is browser. Oh, why I forget that?
You can upload that exam too while you're at it.
You saw my right now. So this is chapter 5. Okay, chapter 5. Okay, submitted. Okay, so this is open until April 1st. Okay, so I attached it now. Okay, so here. Okay, I got it. Okay.
Got it.
Okay. Okay, sorry about it. Too many times. Okay. All right, so let's go to the chapter 3. All right. So chapter 3 and chapter 5 is very, very important for you. Reading technology, the implement of the some system and signal system instead of the the analog component, the circuit board. I think you need to make a program or make a hardware discrete component. Using discrete component, you implement some system. Okay, that's chapter 3 and chapter 5 is very important for you. Okay, so discrete time signals. Last time, so far we did continuous time signal and system. So analog system. Okay. Now the digital system. So in the beginning of the semester, I told you we're going to learn about the signal system, signal processing. Okay, so signal processing, signal analysis. So the signal analysis or signal processing, there are two kinds of analysis. One is a time domain analysis. Another is a transform domain analysis. Okay, transform domain analysis, we have a two domain. In the case of analog or continuous time case, Fourier transform domain or Laplace transform domain. But in the case of, in the case of continuous time and analog system, we using electric circuit in our case, RLC, transistor, diode, operational amplifier, those are the analog component. Using analog component, we can implement our idea or algorithm by using electron circuit. Now, instead of that, usually, we should be able to implement digital, okay, so discrete time signaling system. So by using this discrete component, digital component, microprocessor, ALU, flip-flop, memory, or those kind of the even your program, even laptop, your computer. Okay, those are the digital component. Okay, so also the signal analysis, signal processing, we have a time domain analysis or transform domain analysis. In the case of time transform domain analysis, we have a discrete Fourier transform, discrete Fourier transform, and the G transform. So even in continuous time case, Fourier transform, because of time, we could not cover chapter 6 or 7. But in the discrete Fourier transform, also we could not cover that in this class. So, however, in order to solve our analysis, we're going to learn about the G transform. That is a chapter 5. Okay, so G transform, just like a Laplace transform for the continuous time signal system. So this discrete time signal system, digital system, you need to learn about G transform, okay? So those are the story, okay, overall story. Okay, so this class, the introduction to DT, discrete time signal system, size of, we should be able to measure the signal strength, so size of the signal, similar with the, all procedures are similar. It's a useful signal operation, signal model, and classification of signal. Okay, those are we have, and then discrete time systems. The classification of systems, I think I'm going to skip it because those are the very similar in the continuous time case. And then now, how we're going to build, how we're going to represent the discrete time system equation. Okay, something like that. So those are in this chapter, and then after that, we go to the chapter 5, after learn about the G transform, and we're going to come back. So lecture note 3.2 is covered, okay? A similar way in the continuous time case is chapter 2. Okay, so introduction to discrete time signal system. Okay, so normally we have some problem here. Okay, so this is not analog with signal processor. This is digital signal processor. Come on. Oh, I cannot change it at all. Okay, I cannot change it at all. Okay, so this, I'm sorry, this one is,
Oh no.
okay, so this is, instead of analog signal processor, this is digital signal processor. Please correct this guy, okay? I will using my pen and correct it. So in order to save a battery, so I already take out the battery, and when I need to use the battery, then I'm gonna put it back. Otherwise, battery consumes very quickly, and so okay. Okay, so this is not the analog, that this is digital signal plus. Okay, so digital signal process is even your laptop, computer, software, and all those. Okay, that's all. Okay, and then now however, the natural environment is an analog signal. So analog, it need to change it to digital signal so that, okay, AD converter, analog to digital converter, or in this class, only we can use continuous time to discrete time, CD converter, a converter, and then process it in digital way, process it, and this process is a programmable computer, microprocessor, DSP chip, all those digital components, and then go back to the analog output signal. So we have a DA converter, so digital to converter. So for the system, input is a digital signal input. For the output of the processor is digital output signal. So this digital output, digital signal, change it to analog signal, DA through the DA converter. Okay, this is a example. So instead of the digital signal, this book, for the theoretically, we can use a discrete time system. So in discrete time system, input is a digital signal, just like this, a discrete time signal. So function of n. Function of n is integer variable. Integer means that 1, 2, 3, 4, 5, 6, minus 1, minus 2, something like that. So between the 0 to 1, so the digital signal is not accepted 0.1, 0.2, only integer variable is okay. But in the case of function of t is continuous time variable. So real variable. So any continuous number. So even 1.23556, it can be acceptable. So this is change it to this is continuous time signal is convert to the digital signal here. This one process it and then get an output in digital format, discrete time format, and then we got a DC converter, discrete to continue, okay, continue converter, and through converter, then we're gonna find a continuous time signal just like this guy, okay. So this is the process. So then now, originally, in order to make continuous time signal to the discrete time signal, then we're gonna sample this guy. For example, in G of t is look like this, waveform is look like that. Then we're gonna sample n equal 0, n equal 1, n equal 2, and then between this number, then time period is T of S. So T of S we call this is a sampling period. Sampling period. So inverse of sampling period, we usually say that sampling frequency or sampling rate. Okay, sampling rate. Okay, for example, if a sampling period is long, okay, long, then instead of sample here, then if this is too wide, then we lost many data here. Okay, so that case is related to resolution of the signal. Okay, so minimum number of the resolution is, suppose if you take a Fourier transform, so Fourier transform, the frequency domain, So this is G of omega or F. Okay, in frequent domain, suppose that this is time limited band limited signal. So this is bandwidth. Okay, suppose this is bandwidth, then minimum sampling frequency, minimum sampling frequency must be greater than 2 times T. Okay, this is the minimum criteria for the sampling theorem. So that's we usually say that sampling theorem. So sampling theorem. So because this one is in this class 400, we could not cover this guy, but this is everybody need to know the minimum minimum sampling rate, sampling frequency. So if we have a very high level, high, then the resolution is very good, but amount of data is very high. So this is trade-off. Sampling frequency is higher, is a better resolution, a better good signal. But however, the number of data amount is going to be rapidly increase. So that is a trade-off. Okay, so this is a minimum. So normally engineering cases, engineering point, this is usually greater than equal. So this is 2.2b. Okay, so engineering point. So in the case of the AT&T, AT&T make a commercial. Recently, a phone system is a digital. So our speech understanding is normally 3 kilohertz of voice. Okay, voice is enough to understand our speech in each other. So AT&T sampling frequency is two times, then 6 kilohertz and plus a little buffer. So AT&T using 8 kilohertz. That's a sampling frequency for the phone system. Okay, normal commercial phone system. Okay, some CD, these are the criteria for the sampling, okay, to make a continuous time, a discrete time signal. Okay, so if not, we have some kind of problem. If it is less than sampling frequency, we have some kind of problem. We cannot recover from after we did, in this case, we cannot recover to the analog or continuous time signal. Okay, for example, this is the example. Okay, this is the procedure for the analog to digital conversion, AD converter. First of all, the continuous time signal sample the signal. So this one is a 1.2 volt, the 2 volt, something like that. We can sample. After sample, each sample we can represent by using limited number of bit, 8 bit or 16 bits, something like bit. So that is a digital. So after that, so we have a sampling. This kind of process is a quantization and then coding. So this is the AD converter process is 3-step: sampling, quantizing, encoding. Sampler, quantizer, encoder. Okay, 3-step to make a digital signal. Digital signal, okay, is output of digital signal is a stream of bit. Okay, 0001 is a bit stream of bit. Okay, that's normally we say that this is AD converter. Okay, so AD converter. Okay, for example, suppose we have a Matlab signal generator. Suppose 5 cosine the frequency is 1,001 kilohertz. Okay, 45 degree, and then this is omega equal 2 pi 1,000, 2 pi f, 2 pi f. This is same with the 2 pi over t. Okay, t is 1 over something. This is so that it's sampling period, the period of this cosine function is 1 millisecond. Okay, that case is a sampling frequency, which let's say sampling frequency is 10 kilohertz. So this is more than 2 times of 100, 1000. Okay, so this is enough, and then enough. Okay, so that sampling the t is substituted by n times t over s. T over s is sampling period, or n over this f sampling sampling frequency. That's 1000, something like that. So this guy is 1000 divided by 10,000. Then this one is go to 2 pi times 0.1 n. And 45 degrees of pi over 4. Okay, so using Matlab, okay, the original signal is like this one. Then using n is 0. This is zero resolution, and we're gonna generate using this Matlab. You can try it by using yourself. Okay, so using this, you can generate this guy. Okay, so this is first signal, second n equal 3, n equal 2, n equal 4, n equal 5, something like this. Look at this. We're gonna sample like that.
Did you use a certain formula to calculate that x of n?
X of, okay, I'm gonna give you some after a few slides.
Okay.
Okay.
Gotcha.
Okay, and then this is sinusoidal signal. This is cosine 2 pi over 5n. So this one is omega, distal omega, and this one is distal omega. It's a totally different frequency signal here, a cosine function. This is very high frequency, but after sampling, you see it's the same period. Okay, this is sampling here, this is sampling here, but after we sample, that exactly same signal here, exactly same. So it's confused between this and this. Why this kind of happen? Because this signal is a higher frequency, but this has we said aliasing. Aliasing is, frequency domain, we have some kind of overlap area. So that's the reason, this kind of thing is happen, okay? So aliasing means that sampling frequency is not met 2 times bandwidth of the signal. Okay, so it's not, so it's less than 2b. That case we have an aliasing, something like that. So we normally say that if you're 2b, we usually say this is Nyquist frequency. Okay, Nyquist frequency. Okay, so the sampling frequency must be greater than Nyquist frequency. Sampling frequency is less than Nyquist frequency, then we have an aliasing like that. Okay, that's a sampling. So I think 400 we could not cover this guy. Okay, so just okay for the exponential signal. Suppose we're gonna see exponential signal. This is continuous time signal. So chapter 2 we using this kind of many time. So we're gonna sample using T is NTS. Suppose T is NTS. So this is T changes to NTS. So T changes to NTS. So minus 8 times e to the minus 8 times NTS. Suppose e to the minus 8 TS and parentheses to the n, same thing. So, anytime, instead of writing anytime like this, we're gonna, because this is E is constant, A is constant, T is constant, all constant, and make some kind of number. So that we using gamma to the n. So instead of writing e to the minus 8ts, from now, we're gonna use just gamma to the n. So for example, suppose A equal 2.2 and TS equal 0.1, then 8 times 8 times TS, then this is 8 times TS, so this is e to the minus 0.22 to the n use of n. So if you calculate the e to the minus 0.22, then you roughly 0.8. So instead of writing all this guy, we're going to use 0.8 to the n, something like that. So this is look like that one, okay? Okay, so in this case, it's 0.2 to the n. So normally you can generate, if you have a TI-89, why don't you using this guy, try it right now. So sequence 0.8, something you can do something like this. Can you try by using a calculator? Okay, so I'll do that.
Is that an algebra or anything, or would you have to type out the words?
I think in catalog you can ask, but otherwise, let me see. Okay, here. Okay, so I will show you. You can see my, too many open. You can see my screen, right? Oh, too many. Okay, so let's do this one here. So, you can go to the catalog and then type S, then you can see SEQ. Then my case is easily, I can type SEQ and parentheses and 0.2 to the n, okay, comma, and function of n, comma, and from 0 to 10 point. So 11, total 11 point, okay. So you can do like this. So this is, 1, 0.8, 0.64, 0.512. You can generate like this easily. All right.
Yeah. So is the 0 to 10 the range you like setting for it?
Yeah, 0 to 10 is the first number is 0, n equals 0. And this is n equals 0 to n equals 10. Okay, so n equals 0, n equals 1, n equals 2, n equals 3. So from now, we're going to use, instead of graphic like this, instead of graphic, we're going to use some kind of array or matrix form. So however, we need to indicate the n equals 0 point, the n equals 0 point. So actually, this is n equals 1 point, the n equals 2 point, n equals 3 point, something like that. So only we're going to use error. So instead of the n equals 0, so I'm going to using only error. That error means that n equals 0 point, okay? And then in the case of Matlab, so you can using this guy here, then you can generate, and then using stem n comma x, then you can create like this in Matlab. So you can test whether you can do on a year, okay? You're using this guy. Okay, so I think that's all today, and then I'm gonna stop at this point, and then Monday, Monday we're gonna have a review section. I'm not gonna cover chapter 3, and Monday we're gonna have a review section. So you